Hello again, this is the 6th session on phonetics and phonology. I had promised you I would upload it before, but I haven't been feeling very well. I'm sorry for that. This is almost the final session on this topic, and we're going to see phonological rules today. So, how do we think about phonology and representations? Well, the idea is that we have underlying representations of words. That's how words are stored in the mental lexicon. Then you have phonological rules. The rules apply, and the rules give you the surface representation of the words. Recall, this is a very simplified model of mental representations. If you have classes with Michael Ramska or with Harald Bayen, they will talk to you about much more sophisticated and interesting models of how things are represented in the brain, actually. So, with that in mind, this is a very common assumption, or what I'm going to be mentioning here. It is a very common assumption, and it's very useful for most work in theoretical linguistics. So, the idea is we have an abstract representation of words, and this representation doesn't quite necessarily match the actual pronunciation. So, for example, for Buch in German, we could say that we have the underlying representation with a H phoneme here. And then, because we don't pronounce Buch, but Buch, there must be a rule that derives the actual surface form, and this is a phonological rule. And the idea is that any idiosyncratic property of the words must be stored in the lexicon, but we don't want to store predictable properties. The reasoning behind this idea is that you want to minimize storage, right? So in German, in the word Buch, the B is an idiosyncratic property. There is nothing in the word itself that helps you predict its phoneme. She, on the other hand, is not idiosyncratic. It is predictable. The realization of this phoneme in German can be the sh or h, and it is fully predictable from the context. So, because it's predictable, then we reach the surface form through modifications of the underlying representation. So, what's the context for German? Well, sh occurs after front vowels, after diphthongs, after some consonants, h, l, and n, and word initially. H occurs after central and back vowels, after the diphthong, and after the diphthong ow. So you see the sh form is much more frequent, or is more general than the h form. We assume it to be the underlying form. However, we need a rule that converts from sh to h. And this is the way that we write phonological rules. We have three main elements. The input to the left. There's a symbol that says that it is a phonological rule. We have the output, what's it converted to, and the environment. And the environment tells you in which context does the rule apply. This underscore signifies where the phoneme would be for application. So, in this case, we have the following derivation. We start with the underlying form, which is Buch. Then there is the sh, h alternation and the rule, and you end up with the surface form Buch. And why is that? Well, the sh is following an u in buch, right? So the rule can apply, and you end up with the corresponding surface form. However, if you have something like Dach, what happens? Well, you have the same underlying representation, and you have the right context, and you end up with the surface form Dach. In contrast, if you have something like Blech, well, the context is not correct or doesn't match the rule description, which means that the rule cannot apply. And if the rule cannot apply, then you end up with the surface form with sh. The same kind of process happens in many languages. I would say most languages. In English, you have, for example, an allophone between l and l. This is the dark L, and the context is very simple. L happens word finally, l happens everywhere else. And here are a couple of examples: live, feeling, and feel. And it illustrates quite simply, quite clearly. So, word initially, there is no dark L. Word internally, there is no dark L, and word finally, there is. So you can try to write this rule as a short exercise, and word boundaries are marked with a number symbol. So we have here the rule for velarization, which basically says that the phoneme l goes to l in the context of it being word final. So the derivation for a word like leave, well, in this context it doesn't the rule doesn't apply, so the surface form is leave. For feel, the context matches, so the L goes to L. Here's another example. This is plain screen. I think we had already seen this, but if we haven't, try to figure out what the situation is. If you don't remember, try to figure it out. What's going on here? Well, the observation here in this case is that b, d, g only occur between two vowels, and otherwise you have p, t, and k. If you can see here. So the voiced versions are always intervocalic. So what we can conclude from this is that p and b are allophones, t and d are allophones, and k and g are allophones. And we can assume that the underlying form are the most general ones, so the ones that are not just intervocalic but in the elsewhere position. And we can try to write the rules, and for that we would say, well, p goes to b in the intervocalic position, and t goes to d, k goes to g, etc. We can of course also combine the rule to make things shorter, so not having to write 3 different rules. And basically this notation says that each segment here corresponds to the corresponding segment in the output, and all in the same context. You could, however, also assume the opposite, namely that b, d, g are the underlying representations, and in such a case you could write a rule like this here, where the context is represented as a disjunction of possibilities. Remember that voiceless consonants appear either word initially or before a consonant or after a consonant or word finally, so we represent this disjunction of potential context in curly brackets. So a quick summary, we may have empty environments, so there are rules that apply everywhere, that always apply, the input and output can contain multiple elements. Multiple environments might be specified with curly brackets as a disjunction. Occurrence of vowels and consonants can be specified with these uppercase V and C. So uppercase V is a vowel, uppercase C is a consonant. Rules operate within a domain. So they can either operate within words or morphemes or syllables, and you can mark those boundaries as with the symbol. So the number symbol for word boundary, the plus symbol for morpheme boundary, and the syllable boundary is a dollar symbol. All these rules so far have been allophonic rules, which are about the realization of specific allophones in the different languages. But not all rules are allophonic processes. There are also phonological processes which can convert one allophone of one phoneme into a different allophone of a different phoneme. So they don't have to be always within single phonemes. Here's an example, or we will see an example. Recall that we had introduced the feature bundle description of consonants. Sorry, 1 second. We had introduced this feature bundle description of consonants, right? And this is an M in this case. Now, we can rewrite rules to use feature bundles or features themselves to represent groups of phonemes. A good example of this is final devoicing in German, where voiced consonants go to devoiced consonants, and basically the minus sonorant consonants. And this complete rule can be summarized this way. Basically, consonants which are not sonorant go to being voiceless in the position of in the pre-word boundary position. Here's an example with the word tag. The g becomes devoiced because it's in a word final position. And try to think for a second, why do we know this? Why do we know that the underlying representation must be a g in tag? Or you could flip it around, but why do you think that we don't assume that the underlying representation is tag? Give that a go. Well, the reason is that you still see the g in plurals and genitive. So when you inflect the word in tage or tages, so it's clear that there is something which is either converting the g to a k or the other way around. In this case, we assume that it is from voice to voice. That makes the rules more simpler, a lot simpler. So we can simplify this rule as a minus sonorant goes to minus voiced, and this is enough to describe things. We don't have to specify that it must be voiced plus voiced here, because the rule still applies fine or produces the correct output if you apply it to an already devoiced consonant, so nothing would change. So, summary convention for stating rules: you should use feature bundles when natural classes are involved, so when there is not just one single phoneme, but multiple phonemes. You should use IPA or SAMPA, preferably IPA, and you can use abbreviations like V for vowel, C for consonant, and word boundaries, etc. So now we'll talk about a little bit about the word structure and syllable structure. We usually represent, I think I had already shown you this graphic where you see that we have the word level and then we have syllabic level and then the individual phonemes. So what are syllable? A syllable consists of a sonorous element associated with other less sonorous segments, which must be non-syllabic. Vowels are the most sonorous sounds that we have, and they are usually the nucleus of a syllable, or the peak in sonority. And syllables are composed of segments, and we can organize, and they organize those segments. Some examples. I assume you are all familiar with syllabification. So telegraph has 3 syllables, plant has 1 syllable with one vowel in the middle. And we usually assume the following structure of syllables. This is not universal. It might be the most common one, but some people don't quite agree with this. Basically, we organize the syllable, so we represented the syllable with Greek sigma, and syllables have an onset, which is often abbreviated as O, and a rhyme, which is abbreviated as an R, and the rhyme has a nucleus and a coda. Now, why not a flat 3, but this division into onset and rhyme? The idea, I think, comes from English, and it's due to the fact that there are more, there seems to be different sets of constraints which apply to onsets than apply to nucleus. So distributionally, what can happen in the onset and in the rhyme is different, and nucleus and codas behave more similarly to each other. Now, the onset of a syllable must be a consonant or a consonant cluster, and the rhyme contains a nucleus and a coda, and the nucleus must be a syllabic element, mostly a vowel or a syllabic consonant, and the coda must be a consonant or consonant cluster, which follows the nucleus. So in English, the onset consists of 1 or more consonants, the nucleus must be a vowel or a syllabic element, or a set of vowels in cases of diphthongs, and the coda can also consist of 1 or more consonants. And we can abstract syllable structure as before with the same notation, C for consonant and V for vowel, and write something like CVC, and this is a syllable structure. The syllable structure, this is important, is highly variable from language to language. Some languages have very simple syllable structures. There are a couple of languages which are only CV languages, nothing else is valid, and there are languages like English, and English has one of the most complex syllable structures possible. Probably not the most, but it can get extremely complex in words like strengths, which has a lot of segments, and it's 1 single syllable. So we can describe syllables like this. That's how many consonants there are, and we can give a formal description in this way, being explicit about the position of each element. So here's again the representation, and try to draw 3 diagrams for the for these 2 words, cat and sprint, and see what you come up with. So for cat, it's very simple. You only have one onset, one nucleus, and one coda. And for sprint, it's a little bit more complex, but also quite easy. You have an onset, and the onset is comprised of 3 segments, the nucleus, which is comprised of 1 segment, and the coda, which has 2 segments. And this will likely be a question in the exam. I'll give you some words, and you have to draw the syllable structure. Now, all languages have syllables. Syllables comply with certain constraints, and the speakers know how to divide words into syllables, and they tend to agree. There are some universal tendencies. Nuclei are usually vowels. It's the most common type. We already discussed consonantal or syllabic consonants, sorry, but those are not very common. Syllables usually begin with onsets. Syllables often end with codas, so syllables with onsets are relatively rare cross-linguistically. They do happen, but they are not the most common one. And onsets and codas, well, usually have 1 consonant. More consonants are relatively rare. So an important concept regarding syllables is the sonority hierarchy, and the idea is that phones have an intrinsic sonority. The exact definition of what sonority is very difficult. We can assume that it's some sort of strength or intensity, but there's a lot of research on this, so I don't want you to get the wrong idea that we know what sonority is. We don't fully understand it, but we do know that different sounds seem to have more strength, and those sounds which are more sonorous tend to be towards the center of the syllable. So this is the sonority hierarchy for English and German, and you go from the least sonorous, which are stops, because they have the least they are the least audible, if you want. Then fricatives and nasals, then liquids, then glides, and then vowels. And German is very similar, but it distinguishes between low vowels and all the vowels. And the idea is that in a syllable there's a segment which is the sonority peak, and the segment is preceded and followed by segments which are progressively less sonorous. So the most sonorous segments should be towards the peak, towards the nucleus, and it goes down in sonority. This is a relatively common thing, but there are many exceptions. So it's not very hard to think about situations where, for example, a fricative comes before a stop. Things like that. And that's, I think, a good example of this, right? So a S comes before a T in this case, and also after the P, where I think S should be more sonorous than P or T. So reversals happen. This idea of the sonority hierarchy is more of a tendency than a strict rule. So another important concept regarding syllables and words are phonotactics, and phonotactics is the study of how sounds are organized in a linear order. So not all sounds can happen after other sounds. For example, English allows more than one consonant in the onset, but there are many strict phonotactic constraints. And this is what I mentioned. Syllables can be very complex in comparison to other languages, but there are still a lot of constraints regarding which sounds must come first and which sounds come later. Here is an example of combinations which are allowed. For example, pl, pr, p, spl, spr, sp are all allowed, but p and sp aren't, at least not in English. Tl isn't allowed in English. It is allowed, however, in Spanish or Nahuatl. For example, Nahuatl has tl in it. But not an onset. But in Spanish, you can have things like Atlántico, right? With Atlántico, or tlan, it's the second syllable, and it starts with this onset. So Spanish doesn't have this constraint, English does. And this sort of ordering constraints into which segments can come in which positions and after which other segments is what we call phonotactics. Yes, okay. This is basically writing what I just mentioned before in a more formal fashion. So if you start with an S, you have an alternative of put and k, and l and w are disallowed. So again, in English, the consonant combinations are not random. There are some clear constraints on manner of articulation, and sonorant consonants tend to be closer to the nucleus than stops and fricatives. So again, the summary: syllables are governed by sonority. The segment with the highest sonority becomes the center of the syllable. The functional positions are onset, nucleus, and coda, and the phonotactic constraints tell you which segments can come after which other segments and in which position, and which sequences are allowed. Now, there is a general type of process by which we set up syllables, or how we find syllables, or how they are constructed, which is you start with the nucleus, which is the obligatory part. Then you find the onset, which is the longest sequence of consonants on the left of the nucleus that do not violate any phonotactic constraints. Then you have the coda, which is all remaining unassociated segments in the word. So, for example, we can have a word like extreme. We start then with the onset, with the nucleus, and the nucleuses are E and E. So we associate those, and then we find the longest sequence of consonants which do not violate phonotactic constraints, in this case str. If you were to add the k, it would violate phonotactic constraints in English, because kstr is not a valid syllable in English. And then we associate the remaining unassociated consonants. And this is basically the most common way to find or to order syllabification in a rather like algorithmic fashion, if you want. Yes. Another exercise: try to do syllabification of these words. Applaud and explain. So here it is. Applaud, and here is explain. And that's basically it for this session. I will upload the next one next week. If you have any questions, ask me per email or the tutors. And before I forget, this is actually a good time to go over that. There was a question to the tutors. They sent it to me about why in the phonological table I gave you consonants like l and n were marked as non-syllabic, and why this is also the case for tables specific to English, even though these consonants can be syllabic in English. The answer is in the underlying representations. We assume that the underlying representation of those consonants are or words where you can have syllabic consonants like bottle actually contain a schwa. So bottle with a schwa after the t and the l. Bottle. So basically, underlyingly, l cannot be a syllable nucleus. It becomes a nucleus through a phonological rule which deletes the schwa in certain situations. But we assume that the schwa is there because we can still pronounce it we are speaking very slowly and very carefully. So I hope that answers that question, and yeah, I'll see you in the next video.